Hello everybody, we're getting ready to do section 2.4 of Algebra 2. Here's my contact information for PowerPoints or video, course suites of Algebra 2, solution PowerPoints, online tutoring, tests, worksheets, everything for Algebra 2. This 2.4, factor and solve polynomial equations. We have a skill check at the end of part 1 of 26 points. And then we have notes. Okay, teachers, this is the bell work for your students. Give them about 5 minutes to do this bell work. Okay, welcome back. We're going to have our solutions now for this bell work. About dessert is made by taking a hemispherical amount of marshmallow on a 0.5 centimeter thick cookie, covering it with a chocolate shell 1 centimeter thick. Here's a good diagram here. Use the diagrams to write two polynomial functions in standard form. M of r for the combined volume of the marshmallow plus cookie, and d of r the volume of the entire dessert, which I guess would be that. So here's the volume of the cookie plus the volume of the marshmallow. This would be the volume here plus the volume of the shell. You have the shell plus the original marshmallow here. And then that's a further working out of it. You have volume here. And then this would be the volume of the entire dessert would be used by this formula here for it. So students, put this on a answer sheet, attached piece of paper to your classwork, because this is a lot of work here. Not enough room on the classwork sheet that you got handed out, but you need to attach a sheet to classwork. Okay, moving on here. Before you factor and solve quadratics, you will factor and solve other polynomial equations, so you can find dimensions of arithmetical ruins. So we have previously learned how to factor the following types of quadratics. So general trinomial, we had that. And then a perfect square trinomial, we had that. Difference of two squares, we did that. And then a common monomial factor, we did that. You can also factor polynomials with a degree greater than 2. Some of these polynomials can be factored completely using techniques you have. So a key concept here, and students, this will go into your notebook here. Factoring polynomials. So a factorable polynomial of integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So here's an example here. 2 times these two binomials and 5x squared times this binomial here. Factored completely. That's about as far as you can go with those. And then here 3x times x squared minus 4 is not factored completely, because this could be, it's a difference of a square, so you can factor that further. Okay, students, here is your vocabulary exercise. In your own words, students, define factored completely, and in your own words, define factor by grouping. That's a good one. Okay, example 1, find a common monomial factor. So we have this here. We have a trinomial here. What would be a common monomial that you could factor out at? You just factor out an x, and then you get this here. You factored out a common monomial here. And then you can further factor this by these two binomials. And then say for factor the polynomial completely, what would be a common monomial that you could factor out of this binomial? You could factor out 2y cubed out of this, and you get this. And then you further factor that. It's a difference of a square, and then you get that. So finding a common a polynomial, we're going to find a common monomial that can be factored out of this trinomial. So we can factor out 4z squared out of this, and we end up with this here. And then we can, it's a perfect square. This trinomial factors to that. And then, so okay, if monomial factors factor the polynomial completely. So 30b cubed minus 54b squared. We can factor out a 6b squared out of this here, out of this binomial. And then we end up with this here. So 54m to the 5th plus 18m to the 4th plus 9m cubed. What could we factor out of that? We could factor out a 9m cubed out of each one of these, 9m cubed. And then we end up with this here. Okay, so let's factor this trinomial here completely. Students, this is on you. Factor this polynomial here completely. And if you need more room, students, attach an answer sheet. You already got it from your bed, so use it on that. So for this here, we could factor out an x, and then we end up with this here. And then that could be further factored. This trinomial could be further factored into these two binomials. So factoring patterns in part B of example 1. The special factoring pattern for the difference of two squares, remember that, is used to factor the expression completely. So this is factoring patterns. There are also factoring patterns that you can use to factor the sum or difference of cubes. So special factoring patterns, sum of two cubes, example. So when you have a sum of two cubes, usually we can, this is the pattern that you can follow to factor it further. So for example, we have this here. We have a sum of two cubes, and then the way that we could, the pattern that we follow to factor it further would be this here. 2x plus 3 times 4x squared minus 6x plus 9. Okay, the difference of two cubes. What is the special factoring pattern for the difference of two cubes? So here would be the pattern here, a minus b, a squared plus ab plus b squared. Up here, it was a squared minus ab plus b squared. So there's a sign difference between there and here, and also as well as here and there. So notice that difference, and then here would be an example here of a difference of two cubes. And then this can be further factored into this here. 16x squared plus 4x plus 1. 4x minus 1. And then this here, that's about it. Okay, example 2, factor sum or difference of two cubes. We have this here. We have a sum of two cubes. It can be factored into this. That can go to this here. 64 is 4 cubed. And then we follow the pattern here of factoring that sum of two cubes. And then we come up with this. And then for sum or difference of two cubes, now we have a difference of a cube here. So we can factor out 2z squared out of each one of these. And then this is a cube here. So 2z squared times 2z cubed minus 5 cubed. And then this can be expanded to this here, to this pattern of a difference of a cube, because this would be a difference of a cube here. This is just factoring out 2z squared out of that. Okay, factor the polynomial completely. Students, this is on you. We're going to do this in class right now. So attach a sheet if you need more room. Okay, so we have this here. What are we going to do? We're going to factor out 2b squared out of this here. Then we end up with this. This is a sum of two cubes. This is a cube. This is a cube. And then we expand this out. Here's our pattern here for a factoring a sum of two cubes. And then we plug in here. First we factor out 2b squared. from this, and then we get 2b plus 7, then 4b squared minus 14b plus 49. That would be our expansion here, or a pattern of factoring the sum of two cubes. There's our cube there, and there's our cube there. And then we go into this pattern here. And then this goes down into here. That's our base there of what we're due. And then we go into that. Then a squared is here. So a squared is here. 2b squared is 4b squared. And then AB would be 2b, 2 times b, 2b times 7 would be the negative of 14b. And then 7 squared would be 49. That would be how we would derive this trinomial here from the pattern that we establish. So factor by grouping. Factoring by grouping is when you can factor out an r here and an s over here, and then you get this. Then we have that, and then we can jump to this from here. R plus s times a plus b. A plus b is a common factor to both of these. And then we just group those together like that. Factor by grouping, factor the polynomial completely. So we factor out x squared here from these two, and then these two monomials here can be 16 could be factored out of that. The negative here, don't forget that. Then x squared minus 16 times x minus 3. And then this is a difference of a square, and this is a pattern for a difference of a square. Okay, factor these polynomials completely now. Students, this is you. We're going to do this in class right now. So we have this here. We can factor by grouping here, x squared out of these two, and then a 9 out of these two here, negative 9 times x plus 7. Okay, so these two here. And then we have x squared plus, we have x plus 7, x squared minus 9. That's how we got that. And then we can further factor. We have a difference of a square here, which can be factored into this. So anyway, so that was for Algebra 2. That's 3.4. Contact me here if you have special requests. Thank you very much.